Okay, so meeting has started recording. So good evening and welcome to the third live session of the BA course. Today we'll be focusing on any doubts you may have in connection to week 2 and a discussion on a topic from week 3. So let's get started. Do any of you have any queries from week 2 that we need to look at? No queries from week 2. Okay. Then we'll get started with the topic from week 3. Okay, I hope my screen is visible. An important concept that is covered in week 3 is with respect to uh, the test of independence, chi-square test of independence. So, have you heard of the chi-square test of independence before in your statistics course?
It was there, but it was optional, sir. So I'm not sure if.
No, not able to hear you, Krishnapriya. Yes, no. Have you studied the chi-square test of independence before this? Yes. Okay. So the chi-square Alright, fantastic. So the chi-square test of independence is basically to check whether some variables are related to some other variables in a nutshell. Having said that, how is it? How are we going to differentiate from whatever that has already been learned? That is going to be the point. So I'll come to that towards the end of this. But as a refresher, what is the null hypothesis in a chi-square test of independence? Right? So, what is the null hypothesis? Chi-square test of independence. So, your voice is breaking. Um, all right, just give me a minute.
So can you repeat your question?
Is that now? Is voice clear? It's on and off. Okay. Is it better now? Is it fine now? No. Okay, I've tried all things that are me. Okay. This is the best I have. You will have to add on user something. Let me try to join. Okay, so is the audio fine now? Am I audible?
Yes, sir. Audible.
Yes, sir.
Much better?
Now it's
Seems
better.
slow. Okay, right. Okay. So I was talking about chi-square test of independence. Since you have already studied it, what is the null hypothesis in a chi-square test of independence?
The variables are not independent.
The
Or
variables are not independent. That is a null. Are you sure?
Categorical variables, sir.
Pardon me?
Categorical variables.
Okay. Categorical variables are what?
Independent.
Categorical variables are independent. Exactly. So our null hypothesis is that the categorical variables are independent. All right. So that is going to be the null hypothesis. And the alternative is that the categorical variables are not independent. Okay. Obviously. Now, and for rejection criteria. Okay. Our test aesthetic is what? Since the name implies chi-square, our test statistics is going to be
Observed frequency minus
okay.
expected frequency by whole square by expected frequency.
Expected frequency sum over all. In fact, it should be ij. Oh, that's basically ij. Correct. Okay. And this is going to be distributed as a chi-square. So my test statistic is a chi-square. And my rejection criteria is what? When will my reject my null hypothesis?
If tabulated value is less than calculated value.
Tabulated values, correct. So my chi-square, this, let me call this 0, chi-square 0 is greater than
Tabulated.
chi-squared alpha at a degrees of freedom. Alpha is the significance level and rho is the degrees of freedom. So rho is going to be I minus 1 into j minus 1. That is what it is. Okay. So this is, in a nutshell, the uh, chi-square test of independence. Now comes its application in business. Okay. So let me give you an example. Say you are the manager of a retail outlet, right? And you have two outlets, one at location X and another at location Y. So two locations. So you have two store locations X and Y. And let's say they are very close to each other. Okay. In both of these, you are selling two products. Let's say you are selling ice creams and juice in both of these stores. So there are two products that you have selling in these two stores. Now you as a manager have a feeling that this store and this store, the sales of these two products are related. If one store sells something, the other store will not sell it. Is your opinion. Okay? You have to prove whether it is true or not. That is the goal. Making sense? Everyone understood the problem? Any queries on the problem or
Sir,
something?
can you repeat the last statement alone
All
again?
right. You are the manager and you feel that the sales of an item in store X, for example, affects the sales in store Y. Okay? That's what you believe. One store affects the other, or vice versa. All right? That is what you, as a manager, have a feeling. Okay? So, as a manager, you have a feeling that the sales of an item in store X gets affected by the sales of an item in store Y. And let's say you are selling only two things. You will have to verify this fact. No one is going to decide with feeling. That is where a statistical test is going to come in as a mechanism to check this in the business. All right. So the course statistics teaches this technique. In business analytics, we are looking at business implications of business problems where you can use that particular test. Making sense? Okay.
Yes, sir.
Fine. Okay. Now comes the catch. You want to make, you want to verify the scaling. How will you collect data? You want to verify the scaling. How will you collect data?
We have to collect sales data in both the stores
That is obvious. So what how will you do it?
across time period, like different days or
Okay,
months or
let's say
however.
you should have time. Then what else should you have? Let's say you will have time. One, two, three, four, five. What should you collect?
Sales quantity of item X and item Y. I mean, sorry, store X and store Y.
Sales in X and sales in Y. Is it?
That's what I assume, sir.
But if I do this, this is not a chi-square test. What will
Hmm.
this become?
Number of items per
And that is only sales. Huh? This is not a chi-square test.
It
This
should
can be
it should
done.
be like a cross table, sir. X and Y.
Okay, you will have a cross table, but what will be the values there?
So I think the contingency table would suffice and the value should be ice cream and juices.
Okay, you are telling you want this. Um, you want a continuous contingency table. What will be the row? What will be the columns?
So sir, I think sales in X and sales in Y should be in columns.
Sales in X, sales in Y. So should be in columns. Sorry.
Yes, sir.
Y should be in columns.
And so ice cream should be in first row, juice should be in second row.
Then what is the value here? That you have not told me.
So the sales in shop X regarding ice creams would write. I will write in A11.
Okay, so this is going to be store X and store Y, and the values inside are going to be sales.
Yes, sir.
Super. This is your ultimate table that you want for performing your chi-square. Now my question is, how will you get these values?
By summing up all the collected data.
What is the collected data?
It's a sale quantity.
So how will your data look like? How should your data look like? That is my question.
Ice cream of X, ice cream of Y, and juice of X, juice of Y, and over the different rows will be different dates or something.
Exactly. So I will have X ice cream, X juice, then Y ice cream, Y juice. And this will be collected for different time periods, and I will do a total. And this total will come and fill this table. Okay? Everyone with me so far?
Yes,
Yes,
sir.
sir.
All right. So this is where in your statistics course, you are directly given a contingency table and asked to perform the test. Here, you will be required to collect the data in a business sense, and for that business data, you should choose a test and apply it. And the data that you require will depend on the question that you are trying to answer. Fine? So this is the data that is required for me. Now let's go to Excel. I have created a data. Okay. So this is time
Sir,
period.
a small question.
Yeah, go ahead.
Is there any relevance between the rows and columns, like X and Y in columns or X and Y in rows?
No,
Any relevance?
no. You
No,
can
right?
interchange, the test works.
Okay.
Right. Okay. So let's say this is the data that you collect. Usually it will come like this. So you will have time, you will have store, sales of ice cream, sales of juice. Fine. So this is one way of collecting this data. Instead of having separate columns and time here, I've given time X and its values. Okay. So that is the data. The most important thing to note here is if I'm collecting it for days 1 to 10, it should be the same days 1 to 10 for Y. It cannot be different. Why? Okay. The question is WHY. Why? Why should it be the same?
For comparison purpose.
Obviously. So for comparison person, the time should be same. Why?
It cannot be different. Like, say, for example, we capture one store in weekday, another store in weekend. That wouldn't make sense. So,
Why?
why? Because weekend people prefer or people tend to move out and buy,
No,
and that is
that is
that.
subjective. You're telling about people. I'm
Mm.
telling about the test. Why won't it make sense for the test? What are
Uh,
you trying to compare?
it should have same characteristics. By
What are you trying to compare? What are you trying to establish?
is there any relationship or impact of sales of one store on the other?
So if you compare it on different days, what
Mm.
will happen?
So it will doesn't make a sense to compare different days from different days.
Why?
like for the two shops.
Why? Because you want relationship. Yes, it does not make sense. That is funny. I'm asking you, why doesn't it make sense?
The test results will not be reliable, right, sir? When we do that, when we do not compare data with similar characteristics, then that wouldn't make sense.
Okay, what characteristics?
As I said, like, say for example, you're taking weekday for one store and weekend for the other store, and we conclude that the since the sales has been high in the store Y, it has impacted. There is a dip in the sales in store X, or there is a indirect or inverse relationship between the sales in different stores. We cannot conclude that way because we are taking data or comparing data at different period. It is not in the same period.
Exactly. So I want to say sales of X gets affected by Y. I can tell that only if on the same day I make a comparison. If I make a comparison on different day, I do not know whether the sales has happened in Y and on X on the same time frame. That is the reason. Fantastic. But one observation in what you are telling. This test will not tell you the magnitude of change. It will only tell you there is a difference or not. Which two are difference is not told by chi-square test and by how much magnitude. Okay? Is that clear? In chi-square test of independence, you only check whether they are independent or not. You will not say the magnitude of relationship or the direction.
That means like it will tell us that they are related or not, but it will not tell us whether they are strongly related or they have a weak relationship. Is that
Exactly.
okay?
It will not tell you that. Okay. Right. So this is the data. From this, I want to create the contingency table, which we were talking about. So what is it? Let's go with X, Y, and then ice cream and juice. So what should be the value that comes here? In the
Count of
contingency
ice
table.
cream from X store.
Pardon me?
Count of the ice cream from the
Count,
store X.
count
Sum
or
if. Sum if.
total. So I
Yeah.
want the total sales of ice cream in store X. Similarly, the total sales of ice cream in store Y. And same way, I need it for juices. Here. Oh, I made a mistake. I am doing whether my total sales in X is different from the total sales in Y. That is my thing. I want to compare total sales of ice creams and the juices across X and Y. All right. Okay. Now we can proceed to the test. Uh, this should be fairly straightforward. You guys know it. I need to calculate my observed frequency, expected frequency, and then I can calculate chi-square. So the observed frequencies are this. This is from my sample. I must calculate my expected frequency. Correct? If I just copy this. calculate my expected frequencies, I need the row and column totals. So it's going to be this. Total sales is going to be all right. So I have a total of 547 items, including juice and ice creams, sold in X and Y. Out of them, 270 have happened in X, 277 have happened in Y, 299 are ice creams, and 248 are juices. All right. Everyone with me so far? I'm going fast here because this is from statistics. This is not our goal. Okay. Now I have to calculate something called U and V. And what is U? U is nothing but 270 by 547 and 277 by 547. V is 299 by 547 and 248 by 547. Okay. Then I can start calculating my expected frequency, which is nothing but ui into dj into n. Similarly, ui dj n. Now I got my expected frequency. So I expect X to sell 147 ice creams in this time period, and it has actually sold 139. Similarly, I expect X to sell 122 juices, and it has actually sold 131. The goal is to see if these categorical variables, these four variables, are significantly different or not. Fine?
Excuse me, sir.
Yeah.
Would you please explain how you calculated this expected frequency and what are these U and V values?
U and V are computational coefficients. Okay. So, in your contingency table, let me draw it again. If this is your contingency table, okay, this is O11, O12, O, yeah, 21, O22, right? This is I is equal to 1, I is equal to 2, J is equal to 1, J is equal to 2. In our case, this is X, Y, ice cream, and juices. Okay.
Yes.
Now, this is going to be O11 plus O12 and O21 plus O22. And these are your rows totals. And then similarly, you have column totals O11 plus O21 and then O12 and O22. And then you have the grand total, which is your sample size. O11 plus O12 plus O21 plus O22. Fine? With me so far?
Yes, sir.
Okay. Now you will calculate U and V. So U is going to be O11 plus O12 by N. This is N. Okay?
Okay, sir.
O21 plus O22 by N. And B is going to be O11 plus O21 by N and O12 plus O22 by N. This is nothing but U1 and this is U2 and this is going to be V1 and V2. Okay?
Yes, sir.
Fine. All right. Now we build our expected frequency. We again have X, Y, ice cream, and juices. So what is this going to be? E11 is N into U1 into V1. E12 is N. Whatever is your first suffix, that will be U, and whatever is your second suffix, that will be V, V2. And E21 is N into U2 into V1, and E22 is N into U2 into V2. Okay?
Okay, sir.
Right. So this is going to be your contingency table here, expected frequency. So obviously your chi-square is nothing but observed minus, sorry, yeah, observed minus expected, observed minus expected, the whole square divided by expected. And the sum of all of this. So your chi computed is going to be sum of these. Okay?
Okay, sir.
Any queries from anyone? All good? Wonderful. So now we have to see whether this 2.17 is a chi-squared, is a value which will help me either reject the null or not reject the null. Okay? Please note, in statistics, in any hypothesis testing, we always either reject the null or do not reject the null. We never say accept the hypothesis or accept the null hypothesis. We never say that. We are always either rejecting the null or we are not rejecting the null. Okay? When we reject the null, the one that is left automatically comes. When we are not rejecting the null, we are sticking with the status quo. Okay? So this is the terminology in statistics always. Now the question comes. Let's go back to the original one. our chi-squared value, the one that we computed, which is 2.17. This 2.17 should be greater than our tabulated value. Okay. So how to get a tabulated value? You will have to use a table like this. It's a chi-squared table. In this table, we will have to locate our degrees of freedom. In a chi-squared test of independence, the degrees of freedom is number of rows minus 1 into number of columns minus 1. And in our problem, we have two stores, so 2 rows minus 1 into, we are looking at 2 products, so 2 columns, 2 minus 1, which is 1. So in this table, we will choose the first row. In this first row, we have to specify a level of significance, which is our alpha. And by default, alpha is always 5%. So that is 0.05. You go to the table in 1 degrees of freedom at 0.05. The tabulated value is 3.84. Okay.
So could you please repeat how you chose alpha?
Alpha is given. You determine alpha based on your type 1 error, type 2 error, so on and so forth. You have learned
Okay,
about type
alpha
1 error?
would be given.
Alpha is given.
Okay, on all kinds of questions like this, alpha would be given to us.
Yes.
Okay.
Okay.
Okay, so thank you.
So for alpha, you determine the chi-squared value, which is 3.84. Therefore, chi-square at 0.05 and 1 degree of freedom is 3.84, which is greater than chi-squared computed, which is 2.7, right? 2.17. So we have 2.17.
1 chance.
So what do you conclude?
Do not reject.
Exactly. So we do not reject the null,
Null.
which means what? Which means what? In our problem,
Variables
It
are
is
independent.
correlated.
Historical variables are
the categorical variables are independent is statistics. In our problem, what we are checking?
comparison between.
Yeah. So your feeling that note, it is your feeling, not mine. I'm not wrong. So your feeling that the sales are not independent, they are dependent on each other, is not valid. So the sales are independent of each other. Okay.
Sir, I just want to ask one thing here.
Hmm.
So, as you mentioned the condition above, so is this condition universal?
Which one? This one.
So, this chi-square, yeah, yes, sir.
Yeah. That is the test. That is your rejection criteria. Only if your computed value is greater than the tabulated value, you will reject. That is universal. That is always the
Okay.
case.
Okay, sir.
That is the test.
Yeah. Okay, sir,
Okay.
got it.
Now, how does it work? So if you see, the chi-squared value that you're putting is basically a cutoff point. Okay. So if your value is beyond this cutoff point, then it is very far away from the ideal, and the ideal is 0. So when you are too far away from the chi-square value, you will say you will reject the null. But when you are not, when you are within that limit, you will not reject the null, which is the case now. You are within the limit. Fine? Everyone clear? Any questions? Okay. There was a question on discourse regarding how the rejection changes based on the rejection criteria. And I will explain it with this example. So we have chi-square 0.05 and 1. The value is how much? 3.84. Whereas in the same chi-square distribution, for the same degrees of freedom, if I go to, let's say, 50%, 5.5, the value becomes 0.45. Now, my chi-square 0 was 2.17. When I choose 0.05 as my alpha, I do not reject the null. However, for the same computations, when my alpha becomes 0.5, I end up rejecting the null. Okay? Why is this? This is because if this is my chi-square distribution, at 0.05, I have put up the cutoff region over here, whereas at 0.5, let's say put up the cutoff region here, and your computed test statistic falls in this region. So at this alpha, you do not reject the null hypothesis, whereas at this alpha, you reject the null hypothesis. That is why you call it level of significance. At the level of 5% significance, I do not reject the null. At a level of 0.5% significance, I will reject null. Right? That is why, not in scope for us, but just for your thing, alpha is basically a measure for your type 1 error. What is type 1 error? I will not explain it right now, but it's covered in your statistic. So alpha ensures that you avoid type 1 error, and beta ensures whether you avoid type 2 error. Not as well, but this is what it is. In your video lectures also, if you go see, so we have explained the same thing. At one level of alpha, he would have not rejected the null. At another level of alpha, he would have rejected the null. Precisely, this is what is happening. Where you put your cutoff affects what decision you take, and that cutoff determines your type 1 error. Okay?
So here you are talking that for 3.84, this chi-square test, you do not reject the null. So this means you what is the null here? I just want to know
The
what
null
we
is
assumed.
the null is this. The null never changes. The null is the categorical variables are independent.
Okay.
The null never changes.
Okay.
It is only the significance level that you put that this is true. Significance level basically tells you the level up to which you will say that the null is true. Okay?
Okay. Okay. So understood.
At this point, I will just ask, have you Have any of you learned p-value? Have you been taught p-value in statistics?
So I learned it, but I didn't remember it now.
Okay. Anyone else? What is p-value? No one remembers. A very, very important concept and a very, very basic concept. P-value is probability of observing a sample, observing this sample given the null hypothesis is true. Okay. So I am telling that the null hypothesis is true, and what is the probability of observing this sample? That is p-value. Okay. Now that I have computed a chi-square, a chi-squared 0 of 2.71, what p-value do I get? What is the p-value for chi-squared 2.71? That is the question. That again you get by going to this table, choosing a level, choosing a degrees of freedom. For our case, it is 1. And you try to see where 2.17 falls. Sorry, our computed value is not 2.71, it's 2.17. Okay. So 0.002.45.27. So my chi-square value is falling between these two, 0.45 and 2.71, more closer to 0.1, right? So the p-value is between 0.5 and 0.1. Now, is this significant? That is the question. So if your p-value is less than the alpha, then you reject the null. Okay. In our case, we have taken an alpha of 0.05. Since 0.5 to 0.1 is not less than, or let me put it like this, is greater than alpha, which is 0.05, I do not reject the null. So my p-value method and checking it with a chi-square value both yield the same result. In one, I tell you the probability of observing this sample given the null to be true. In the other technique, which is comparing of the chi-square values, I establish a limit and tell if it is falling within my limit, then I do not reject. If it is falling outside my limit, I reject my null hypothesis. Okay? Both mean that both techniques will result in the same conclusion, but they are different ways of doing it. Fair enough? Yes, no.
So if p-value is equal to alpha, then what will happen?
P-value is equal to alpha, you will still consider it as not rejected. There is no significance. It has to be lesser than alpha, greater than or equal to, you will say not rejected.
Okay, sir.
All right. Uh, so that is the chi-square test of independence and the application in business. Whenever you want to see if the whether something is related or not, you will use this to do a test. Okay. Let's say you reject the null. At 50%, you reject the null. Then all you can say is that the sales of ice creams or juices in X or Y are not independent, right? They are in some way dependent. You can never say the magnitude. You can never say what is dependent on what. Whether ice cream sales is dependent on stores or juice sales on stores or ice cream sales is affecting juice sales. None of that you can say. That requires further examination. Fine? Is it clear? Any
Yes,
queries?
sir.
Yes, sir.
Okay. So this is in nutshell the chi-square test, its application in business, and the focus in our course. Just one small thing, instead of doing all of this in Excel, you can directly get a p-value by using this command, chi-squared test. Okay, CHISQ dot test. It will ask you the actual range, which is the observed values. Then it will ask you the expected range, which is the expected values. Once you input the two, you will get 0.14, which is the p-value. So 0.14, which aligns with your table. 0.27, 2.7 is zero point 0.1. So something before that is lower, and before that it's going to be 0.14, because as you move towards the left in this particular table, the value increases. So zero point 0.1, 0.2, 0.3, 0.4, 0.5, and we set our p values between these two. In Excel, it actually calculates that exact value and tells you that it is 0.14. And this is going to be greater than 0.05, so do not reject the null. Okay? That is the chi-square test in Excel. Of course, for this also you need to get the expected frequency and the observed frequency. Fine?
Yes, sir.
All right. So this is what I had for today. We are on time. Any other queries from week 3? Have you all seen week 3? Let me ask that question first.
Yes, sir.
All right. Okay. Good to
Sir,
know.
not yet.
Not yet. Okay. That was expected. Any other queries from week 3? Any queries from week 2? Anyone who has not seen week 2 also? No one of that sort. Fine. So in week 1, we talk about visualizations and it's important in business. Week 2, we talk about establishing what distribution the data comes from, chi-squared goodness fit. And in week 3, we talk about chi-squared test of independence, whether categorical variables are independent or not. That is what is checked here. So this is the business perspective of the statistical tools. Uh, Please feel free to use the discourse in case you have any queries on this. And meet you again next week on Tuesday, if you do not have any further queries.
Excuse me, sir.
Yeah.
So actually, there was a question in week 1 practice assignment. I just want to know the concept from you. that in that question number 15 we have across all the items the country wise proportion of item A being sold. So what should be the correct visualization for that? So there was a bar chart, scatter plot, and I think a tabular format. So
Practice
why?
problem, right?
Yes, sir. Practice problem.
Just give me 1 minute.
Last question.
Let me just open it up.
That questions are confusing, sir. Message and communication.
Ah. I believe this was the question, right?
That question.
No, sir. It was question number 15 from practice assignment 1.
That is fine. The number will change because we have split this, but just check whether this is the data. Table 1 provides complete sales of an item A, B, C, D, E. Then the message for each question or just the graph. Will obviously the number will be different.
Yes, the question is same,
Question
but
is
I
same.
just want to know about the visualization part.
Exactly. So every graph has its purpose. Okay, so that was your first set of questions. What graph, what purpose? Now, in this, the message that I want to convey, let me take the first one. Country with the highest sales for each item. What do I want to present? I only want to present for each item which country has the highest sale. So what would make sense? What would intuitively make sense?
Bar chart.
A bar chart.
Yeah.
So I will have to choose a bar chart. And I have several of them here. I have this one, I have this one, and I have this one. Why would D be the most preferable? D would have been the answer. Why would it be preferable?
Because it says product wise the highest country. So A,
Even
B,
this is
C.
telling.
No, this is telling country wise products, right, sir?
Okay, country-wise products. Fantastic. Even this is telling you have A and you have different countries. So this is also giving you that.
It's grouped together with the color coding, so which is easy to understand and capture it.
One reason, another reason. Look at the message. What is the message? The message that I want, sorry, let me go up. The message that I want is this.
It's not sorted, sir, the small bar that you said.
Okay. Even this is not sorted. Is it
But then
sorted?
the scale is so visible
But
that we
still,
can.
it's grouped together with the color codings, which is easy to understand. So, like
That is
you
one way
can,
of presenting. But
yeah,
look at what I am doing. I am interested only in the country with the highest sales, which means I am not bothered about the other numbers for any of the other countries. Fine. In all the other charts, I have given you numbers for other countries. But here, over and above the groupings with respect to colors, I am also giving you only the maximum value, which means my eyes will immediately focus on that number and pick the country. That is why this is the best answer. Color coding, yes, no, that is all added effects. The first effect is I look at it, I will look at the bar with the number and choose the country. Okay? Srishti, did I answer your question?
actually, she asked 15th one, sir.
Uh,
The last one.
Yes, sir. The 15th one. Yes, sir. This one.
this one? Okay.
Yeah.
What is it? Across all items, the country-wise proportion of item A being sold. So what are we looking at? I want only for one item, and I want country-wise what proportion is being sold. Fine? Okay. This one, okay, whenever I say proportion, what is the graph that should immediately pop up?
Pie chart.
Pie
The
chart.
pie chart.
Pie chart. So do I have a pie chart here?
No.
No. So I will have to choose the next best alternative. Right. Now I have this bar. Bar charts, even though I have put proportion, I will not know the total. Okay. So this is out. Sorry. Okay, pie chart is not there. Sorry. Pie chart is not there. So I must choose the next best alternative. And I want to choose whichever options tell me the proportion. This one tells me proportion. And in fact, it's also sorted. So I can choose it. Fine. Here also, it is the same thing. Only instead of a bar, they have given you circle bars. That is all. So this is also fine. This one is not good. Why?
Maybe sir, because it's not ordered that way.
No, not fine. Ordering is not good. But I'm only worried about proportion. I'm not worried about which is maximum limit and so on and so forth. Only proportion. So why is this not correct?
For some countries, proportion is not given.
Exactly. So I have not given it for India, China, Great Britain, so on and so forth.
Yeah.
This is the best among them. It is right. Why is it right?
Because of sir color scaling, I think.
Color scheme alone.
No sir.
One is color scheme. Color scheme is right. But option D, then this is option D. What else? It is looking small, fitting. It is cut size. So it is immediately telling me all the information that I need, and it's also pointing to the one that is maximum instantaneously, 0.23, because of the heat map. So this is the best amongst everything, but all of these A, B, and D convey the message that I wanted. D is the best, but A, B, and D all convey the message. And since I've asked you only those graphs that convey the message, you will have to give me this. I have not picked which is the best to convey the message. This is the best, and D, A, and B convey the message to me. Okay?
Okay sir, fine.
Right. Here,
Thank you sir.
okay. Here, the reason why I have not given you a 5. Let's say I put a 5 for this. What would be the problem?
5 is not preferable when you have more than 2 classes, sir. So
More than
like,
4.
So more
Yeah.
than 5, I think.
I think it's around 4. Either 5, not 2. If my memory serves right, 4 or more becomes a bit crappy. So you don't know, you have a large number of things. What it will do is it will group it into others input. Then for others, you have to again specify what they do, which will not convey this particular message. That is the reason. So as the number of categories increases, pi becomes difficult to interpret. So you go for other methods. Okay. Right. Any other questions? All right. Okay. So do try the others. Visualization is a bit subjective. So there will always be some confusion around them. But the general principle is what is asked in your question 6 to something. All right. 6, 7, 8, 9, 10, 11, 12. Yeah, question 6 to 12 in your practice problem will help you choose the graph for the given scenario, best graph for a given scenario. Even there you have some subjectiveness. Okay.
Sir, I have a question regarding quiz one. Will we have any mock test or anything of that sort?
No. You will not
No.
be having mock tests. Please take previous year QPs. This is the
Mm.
fourth term. So you should have at least 8 past QPs, quiz 1 and quiz 2, 4 for each. So that should be sufficient for practice for you guys. Okay.
Should we take quiz two previous papers as well for quiz
You
one
can,
because
because there will be some overlap.
okay,
Quiz 1 syllabus is 1 to 4, quiz 2
3 to
syllabus is
8.
3 to 8.
Yeah,
So
okay.
there will be overlap.
Okay. Thank you.
So we will be entering the quiz without any assignment, is it? Fifth assignment will be coming after quiz 1, is it?
I believe it will be launched along with week 4 content. This is week 3, right? Most probably this week or at the end of next week. I don't remember the exact date. It will be launched alongside. Usually it will start before the quiz and end after the quiz.
No, but
But
we
will
are.
there be any graded assignments, sir?
Pardon me?
Will there be any graded assignments before
No
we
graded
attend the quiz
assignments.
1?
No graded assignments.
Yeah, we will be entering quiz 1 without any graded assignment. No, we are not
Yes.
tested ourselves.
You are given practice problems and past question papers to test yourself. That is how this
So,
course works.
so from week 5 will we get graded assignments, sir?
Graded, not graded assignment. Okay. When you mean graded assignment, there are two things in this entire program. One is people give it to you every week, and the other is an assignment. We are giving you an assignment, 3 assignments in total. The first one at the end of week 4 or at the beginning of week 4, I don't exactly remember. That is going to be one.
That is given as week 5, sir.
It is given week 5. Okay.
Yeah.
So that is going to be one. Then you will have another one, most probably week 6. Then you will have one in week 8.
So that means
So all
before quiz 1, 2, and 3, one assignments will be there. Each quiz you will
Not
get
1,
one
2,
assignment.
and 3. There are only 2 quizzes.
Oh, sorry,
Quiz
only
1
two
and quiz
quizzes.
2.
Yeah,
Yeah.
yeah.
So after week 8, is there any course content or what will be the agenda for that?
There are course content. The course is for 12 weeks. Unfortunately, the website is not yet updated. We will get it updated soon. So the course is 12 weeks. All right. Your grading document has a small update. You have 2 quizzes, quiz 1 and quiz 2. And your quiz score is going to be 0.7 into max of Q1, Q2 plus 0.3 into max of Q1, Q2. Sorry, min of Q1, Q2. This is going to be your quiz score.
So the link for this session would be updated in the calendar, right?
It is there in the calendar. You have joined
No, sir. The recorded link.
the recorded link, yes, it will be there. It will be there on YouTube.
But sir, the link to YouTube is not like.
Just write to the support team now. They have created it. I believe last week they have created. It's updated.
Okay, sir.
Just go check it out. We have a channel in YouTube. There it will be there.
And what about the calendar entry, sir? That also we are not able to view it, sir, actually.
Which calendar?
This, no, for the BA related live sessions.
It's updated in calendar.
Yeah, it is there.
No?
Okay, actually, I have joined this through Gmail, which I got in my mail, but I couldn't see in my calendar. Okay, I'll just go and try it again.
Syncing is not done.
Sorry?
Go to the course in Seek. There you will have a calendar. Choose it and sync it. I believe you have not yet synced.
No, sir, even I tried yesterday also, but it was not showing. Then I just joined from the mail only. Okay, so
I
no
also
problem. I'll just
tried
go
for
and try it.
Week-2, but
I'll go.
if you're doing in mobile, it is not happening. Just once do in laptop.
Okay. Okay. Then I'll try from laptop.
I'm
Okay.
doing from
Thank you.
mobile.
Thank you.
If it
Thank
is
you.
not showing, you should go to show more and then it will appear. And then you have to click on sync.
Okay. Thank you, English. I'll just try that as well. Thank you.
I'll do one thing. I'll stop recording. I believe there are no more queries relating to this.
So one last query. All the three will be case studies, no? Similar to BDM, what we have done. Like
Yes.
all the three will be. Okay.
Yeah.
Thank you,
All
sir.
the three
Thank you.
are
Thank you.
database case assignments.
Okay. Thank you, sir.
Okay. Yeah. So this is going to be evaluation criteria, but more importantly, yeah. More importantly, it's your assignments. So to be eligible for the end term, you need to solve A1 or A2, assignment 1 or assignment 2. If you do not solve one of them, you will not be eligible to give the end term exam. Okay, so at least one of them is required. The rest should be available in your grading document. All of this is available in your grading document as well. So please make sure that you attempt either assignment 1 or assignment 2. Fine.
What you said now is for end term, right, sir?
Yes, I'm taking this for
Okay.
enter.